yeah, can you see my screen? Hello, can you all see my screen? Hi, can you see my screen? No, you're here. Oh, sorry, hide. So I didn't know I was muted. Hi guys, welcome to our Solidity 101, and I'm glad that you joined in. Can you guys see my screen?
Yes.
All right, so that's
Yes,
great.
I can.
Thank you so much. So we're just going to go back to the basics. So what I'll be doing for you right now is I'm going to be taking you all through Solidity, and I'll advise you on your own later on to go through the resources that were provided in this class. Please, can you mute your mic? Unless you want to say something, that's when you can unmute your mic. Thank you. So now we're going to start with Solidity. So first, my name is Blessing Emma, and I'm a blockchain engineer and a devil advocate. So after this class, I will share this PDF with the group so that you guys can go through all the resources later on. So there, if you want to reach out to me, you can reach out to me on Twitter. So now about Solidity. So Solidity is a statically typed, Solidity is a statically typed coily-based programming language. Now, Solidity is the language that we use to build smart contract on Ethereum blockchain, and you all know about Ethereum blockchain. So that Solidity is the language you use for it. Other blockchains have their own language, or it depends on their EVM. Like example, Stacknet is an L2 and they use Cairo for that. That's their own language. So Solidity is the language that we use. And it has some similarities to something like C, C++, Python, but generally, at first, when you get introduced to the language, it may look like gibberish, but over time, it gets clearer. So if you have any question, you can let me know. Now, the reason why I put this here is because of in your learning, these are the major places I recommend that you should go and learn. So learnweb3.io is the resource that we're going to be using to learn about Solidity. And then we'll also be making use of Solidity by example. So I'm opening Solidity by example to show you guys. Okay, this is it here. So this is how Solidity by example looks like. Basically, on your free time, you can just go through each links, and then this is talking about different hacks and tests, DeFi, and basically applications. And these are like the basics. These are like everything that makes up Solidity. This is a very good resource while you're learning Solidity. Now, Solidity documentation is the doc that is owned by Open Zeppelin themselves, and this is like the go-to document if you want to understand more things in Solidity. And since I can't find Solidity by example, you'll find it here. So this is more of the recommended documents that go to Solidity. Now, this VS Code is just like where you're going to be building on your laptop. You use VS Code, it's a development environment, and you can write different programming languages there. Now, Remix is an online IDE. IDE stands for Integrated Development Environment. It's basically a place whereby you can write your smart contracts without actually using VS Code. And now, I don't know if I put it here. Sorry, let me check. Oh, sorry. There's something that was meant to be here. Hard hat is, I will show you guys soon. So this is how Remix looks like. So basically, this is like contract. This is an example of a contract here on Remix. So Remix is more like an online IDE. So when you basically download your VS Code, you have to now set up hard hats. Hard hat is basically the most popular Ethereum development environment. There are other ones, this Foundry, but this is like the basics that everyone uses. So this is like the recommended one, but this one is a bit more advanced. So later on we can share resources for you guys to get familiar with hard hats. So this is like where I would advise you as newbies to focus on writing more contracts. And this is like a basic contract. This is a storage contract. This is an owner contract. and ballot contracts. So, all right, back to where we were. Now, back to our Solidity basics. So now in basics, I'm going to be talking about different kinds of things. Now we're going to talk about variables. So when we talk about variables, God Almighty, sorry, give me a minute, please. Hey God. Okay, how does this thing? All right, we're good. So talking about variables, now most of these things, as you're seeing them, they are links. I linked them to Solidity by example, so that when you have access to them, you can understand them more. And this is like primitive. These are like different. These are, I will call them the basics of Solidity. You need to know about the variables, different kind of variables, the primitive data types, even data locations, and then the other things that you have to get more familiar with. All these links, they are all linked to Solidity by example, whereby let me just enter into this word so you can see. So this is what you basically see. This is Solidity by example, with them breaking down what local variables are, state variables are, and even what global variables are. So can you guys hear me clearly, or is any noise disturbing you? Basics, because of they are the things that you need to know. So now in variables, all these things here are linked solidly by examples, and in variables we have local variables, state variables, and global variable. The reason why I'm going through this approach is because of right now I don't expect you to know all the whole syntax. I want you to get more familiar with it. So when I say local variables, you need to just understand basically that, oh, this is what a local variable is, and this is how it is written. You don't need to understand much more, and this resource will really help you a lot. So like now, as you can read here, so a local variable is declared inside a function. Now let's just give you example. This is a local variable, and now for them to declare int I equals to 456, the fact they put it inside this function, that's what makes it a local variable. The fact that it's inside the function, that's all. And like these are just extra things, it's not stored on the blockchain. Now state variables are declared outside a function, and state variables are like, now this string public text equals to hello. This is a state variable, it's declared outside the function. This is the function here, but outside it, this is it here. Now global variables, like it says, provide more information about the blockchain, and that's things like block.timestamp. If you go to the Solidity, hello, can you guys hear me?
Yeah, sure.
All right, so
Yeah, so we can put on your mic.
all right. So good. So sorry, I'm coming. Continue recording. Now, so I'm going to show you example of global variables, and I showed you the ones by this ones here. This is block.timestamp. It basically lets you know the current block.timestamp, like that. Basically, the current time a block was deployed on the blockchain. Images of sender tells you the address of the person that is calling, probably a function. Now I want to show you how to use the Solidity docs. This is the main docs that global variables to like search for things. So now we want to look into global variables to see more of them. Okay, coming. I want to show you like basically more global variables. Now can you see the cheat sheet? Now let's see operators. Yes, now this is it here. These are all the global variables. For now, you don't need to know them, and you don't need to memorize them. As you are learning Solidity, it's become more familiar. Like example, images of sender is the most common one you use. For tx.origin, when you start deploying contracts, you get more familiar with it. But these are examples of global variables. Now, back to where we were. These are like that's all about like variables. I would advise you that when we are done with the class, you should just go through the resources again, and also just practice more your own. Now moving into primitive data types. Here is just like how these are just like the basic of all language. A boolean, a uint, an integer, and an address. That's basically what we use to that's basically what we use now that's basically what we use as, let's just say, our data types. Now people talk about a string. We can't call string really like a data type. Some people say that it is, but it's not really that much. A string is just like, and just you put in a string will allow you to write text like hello world or how are you, like basically in the form of a sentence, but just put the quotation. But now when you talk about the primitive data types, are the ones that we have. We have a boolean, and a boolean is what? Who knows what a boolean is?
True or false?
Yes, correct. So it's basically the same knowledge that you know in other programming languages that apply here. And now an address is this address public here. This is an example of an address on the Ethereum blockchain. Can you see this here? I think it's 21 bytes. Yes, 21 or 20 bytes. But this is an address. Like for you to interact with a blockchain, you need an address. And even contract also at the end when they're deployed, they also get like a contract address. And basically everything we use to track on the blockchain is through your address. You get to see what someone does on the blockchain through their address, and this is how it is written. Like now, what you're seeing right now is that when we say that Solidity is a statically typed language, what do you guys think that means? Statically typed language. Can you guys hear me?
Yeah, well, I think, I don't know, probably doesn't change. It's not dynamic. I don't know.
Okay. So when we say statically typed, it means that before you actually define probably a data type, you have to define like the type of it. Example, before I say blessing, I have to determine that do I want blessing to be a boolean, or do I want blessing to be a string, or do I want blessing to be an integer. Integer is basically numbers in Solidity. Or do I want blessing to be an address? Like now, let me use the example of this our address. This address is a type, right? Is the data type, right? You guys. So address is a data type. I'll still come into this later. Sorry, no. I'll still come into public later. But right now, address is data type. Now, this determines that this is now the name of it, ADDR. And that means that whatever comes here, it has to be in an address format. If you put in example blessing, it can't work because of Solidity is expecting you to basically drop an address, but you went to go and put in a name, blessing. If you had put in a string, sorry, I'm coming. So now this is like an address, like I said. Solidity is expecting you to give them an address, and if you go and put in blessing here, it cannot work because it's expecting an address. Now, other types that we have is, let me see in this one. Okay, now this one is now a boolean. If you now put in a boolean, basically tells you if a statement is true or false. If you put in boolean and then you named your boolean that boolean is default boo, and then you put equals blessing, it won't work because we're expecting either a true or a false. Now, when it comes to types, there's a default of everything. A default means that if you are starting from the scratch, what will it be? So the default of an address is basically address OX, and then a default of an integer is 0, and a default of a uint is 0. The default of a boolean, that means it's false. It's always going to be false. It's now you. Whenever you're making use of a boolean, that means that it's always going to be false. It's you that then changes it to whether it should be true or not. And a uint basically is an integer. It's just like one stands for unsigned integer and one is basically normal integer. And the difference is basically one is positive, one is negative. Unsigned basically is the positive, and then int is now the one that is the negative. Int is like basically for negative numbers. Why? Unsigned is more like for positive numbers, you can see here. Now this other part, data allocation. So when we talk about data, are you guys understanding? Are you following me? Hello, Austin, Shay, can you guys hear me? Tifer,
Yeah.
Yes, we can. I'm following.
do you have any questions so far? Okay. So my advice to you,
So far, no question, but not that I grabbed everything you said
yes.
so far. I would definitely have to look through the materials when you're done, but so far I have no question.
Okay, no problem. Right now, just sit back and just look at it all. It's all going to look G because this is your first time. But then just give everything time and you will get it. Okay? So now I'm moving into like data allocation.
Yeah.
This is talking about how do we store things on the blockchain. I know everyone talks about like, oh, the blockchain is decentralized, autonomous, but can you really store data on the blockchain? And the answer is yes. You can store data, but there's some kinds of data that they advise you not to store on the blockchain. Some people do it, but example, data that are live. Example, when it comes to healthcare, people store their own healthcare like in data on the blockchain, like private. If you have a private blockchain, that means that it's something that's accessible to the public. Right now, Ethereum is a public blockchain. That means that anyone can access it. But now there are private blockchains out there whereby people don't really cannot access them unless they are given permission. Now, when we come to like how our data are stored, now there are three kinds of way. No, there are actually more, but let us say for the basics, you just need to know these three. This one is a storage. We have storage, we have memory, and we have cold data. And the storage is basically stored on the blockchain. While that means that whatever is inside storage, it means that everything that you are writing is going to be stored to storage. Now, memory is more like, let me use what a parameters. Can you see this function G? Can you guys see this where my arrow is pointing at?
Yes.
All right, thank you. So like now in this function G, you can see that it's saying a uint, that's an unsigned integer, and then it's saying memory. Now what we are doing right here is that we're saying that what we are getting in this function, you don't need to understand the function. It means that it's all going to be temporary. It means that whatever we're getting in this array here, it's just going to be temporary. That means it's not going to start on the blockchain. Once we get it at the end of this function, you don't need the data again. That's what it means. That's what it basically means for memory. And call data is also very similar to this. You can see variable is the memory and is this why a function is being called. Call data is mostly like has to do with function arguments, and it's like almost the same to like memory. Memory has to do more with what you are calling within that function, while storage has to do with everything on the blockchain. That means everything you are writing is stored on the blockchain, and everything on the blockchain costs gas. But now memory now helps you define that, oh, this one is we just need this function when we are calling this. We only need this information when it's being called, and you don't really need it will not really take much gas. Call data is more like a function argument, and it just has to do with like, okay, this is what we require to move forward, and just store it temporarily. Once we are done with this function, it can disappear. While memory is more like, okay, only when we need this function I can call it. Now, so these are other types of now these are that we call them basics because of right now you need them mostly. Like now you saw something like an array. Like in this previous function, this is an array. This will I call it rectangular mouth. This is how you get an array in Solidity. This is how you say something is an array. Now those are things like example, as you can see through this contract here, you can see that there are so many different things going. You can see there's a struct, there's a mapping, and then there's even like internal, and there are more things here. These things are mostly basic things you have to learn, but right now just know that we're just going to skim through it, and later you can review it. Now, a mapping, let me give you an example of a mapping. Let me see, mapping. Now, can you guys see this function F? Can you see function F? So function F, under function F, we can see the type. The type is what? A mapping. And this is how you write a mapping in Solidity. Uint to address. It means that we want to probably, let us say in this contract now, we want to say that, okay, we want to link that one, let's say one token belongs to this, or one token goes to this address. Remember what I said about uint? Like, it's mostly about integer. So one token goes to an address. And this is how you create mappings in Solidity. Just like mappings, like now another one is this one. A mapping is a data type, and then the uint is mostly the where you are calling. There have to be two parts of it, a key value pair, and this is the key, and my sort is the value. So from this to this, that's majorly it, and then you now name your mapping. Okay, moving on. All right, so I know that you may not be familiar with all this now, but let's just say as we progress and as you go through the materials, you will understand it. Now, let me move to enum. Enum is mostly a way of just, let me use the word like, when you want, example, now, let's just say this status that is here, enum status, is you want, there are different answers that you're expecting, but now you cannot store them, you cannot just store them anyhow. And enum basically allows you to give people different choice, but it's all inside one. So like status, now we have the option of pending, shipped, accepted, rejected, cancelled. It's just like lots of information into one, and it's a way of keeping track of like the state, or keeping track of what's going on in a particular format. So I would say the contracts are like now. All right, so let me go through this contract for you. So the name of our contract here is enum, and then they define this type. This data type they use is enum, and the name of it is called status. And these are the things that the enum contains. So yeah, they are now calling like, okay, we are calling the data type enum, and we are saying that it's also status. And we want to get, example, function gets. You guys don't understand this one. All right, let me just move into cancel. So now function cancel public is now, you want the status, that means this one, but inside that status you want to call the cancelled. The cancelled is like inside this enum. So that is what you want it should happen. Enum basically allows you to do, you have many options you want people to do, and then you want to be able to track them all within one part, and that's what an enum allows you to do also. Okay, so move on to the next. Now for there are like so many parts of it, you can't get them all on one call, but these are like basic things that you will need to understand. So let me just say a function modifier, a function visibility, view and pure function, a constructor, and an event. I want to go through a smart contract for you guys. I'm coming. Oh, this is an assignment. All right, so now before I go back here, I want to show you. So this is your assignment. I know right now you don't understand what's really happening, but we're going to do something whereby at the end of it all, when you're done learning, when you're done with your learning, I want you to build a voting smart contract with Remix. That means you're building it on Remix. Try to just play around with the different things that you're learning, and that's your first assignment. Second one is basically you learn how to use Hadat and on your VS Code to build a smart contract, and if you can deploy it, sure, no problem. And the last thing you're going to do for us is that you're going to make a tweet of your learnings online. That way people are able to hold you accountable to your learnings. And let's just move back to this one before I show you my smart contracts. Okay. Right. So. Okay. No. Where is what I did? Right. So another, guys, I don't know those of you that are not using learnweb3.io. This is what we recommend for everyone to use. Oh, I'm in the wrong address. I'm in the wrong account. That's why. We recommend that for everyone to use because of it's very easy. Sorry, I'm looking for an account, one of my accounts. Okay, learnweb3.io is basically the recommended platform that we advise you guys to use to learn about Solidity more. It's to teach you about, like, now for those people that have enrolled, this is like the novice track, and you are going to learn about blockchain, Web3, Ethereum, and then this part here has like a Solidity intro part. So yeah, they are basically breaking down everything that, let's just say, what I taught you now, they are breaking it down much more. So let's just say, like, now in reviewing what they are doing in a smart contract, let's just review their smart contracts now. The first thing you do when you are writing a smart contract is to define. Normally we do this stuff whereby we say that we do the, what do we call that thing? So what do we call this thing? Okay. So this line here that we use, this is not this is my own contract that is too long. Okay, let me use this one. Now, we basically define the license, and we normally use SPDF license identifier, and then we now use MIT. Now, the first thing you have to now do again is to define the Solidity compiler version. That's what we have here, the Pragma Solidity. Now, this greater than shows that, we want to use what Solidity we are writing should be is above this version, because of every year there are improvements in Solidity. It's the industry is less than 15 years old, and the language is always changing, so there may be like improvements in some data types or in some things like that. So that's why we have to keep on learning. And now, once you do, like, now you define, someone joining in, or do you have a question? Sorry. Okay, Key, raise your hand. You can speak.
Yeah, I did.
Okay.
Good evening.
Good evening.
Yeah, I wanted to ask because I joined the class late. Yeah.
Okay.
So I wanted to know where with the these teachings would you be like pasting it on WhatsApp or something like a screen record?
Okay, yeah, I'm actually recording the class I'm teaching, and so far I'm using these resources that I created. Sorry, can you mute your mic? Thank you. So I created the resources for you guys, basically a breakdown of the language in terms of the basics, and then the intermediate things you have to learn, and then some major other things. So I can't teach you all this now because of this is your first time here, and this resource basically contains like learning resources for you. So after the class, I'm going to share it with you, and you on your own you go and review it. Now where you caught me now is basically like I'm trying to show you guys how this is the recommended resource that we advise everyone to learn, and that's where I was here. So this is learnweb3.io. This is to teach you basically like the basics of learning of blockchain and even Solidity itself. So now what I taught you guys in my own Solidity basics, this is what we're reviewing here. Now, and I told you guys that the first thing we'll just do is put our license identifier, and we use MIT. That is this thing here, this SPDF here, this part here. That's it. And next one is our compiler version, and then after that one is now going to be the type. That means the contract, like we said, Solidity is statically typed language. That means that almost everything you have to define the type. So just say like, okay, it's a contract, and then this is the hello world. This is more like a breakdown of a smart contract. It's the same thing I showed you guys on Solidity by example, and I would advise you to just go through this. So I can't teach you this in one sitting. This is an array. Array is part of what I told you that you need as a basic learning, and they reference Solidity by example, and there are other more things here. I don't recommend crypto zombies. Why? Because of there's some things there that are outdated, that are not updated. In terms of, yes, you know how each day we have new versions of Solidity coming out. Crypto zombie, they don't really update theirs like that, or it's probably very slow. And if you are learning something, I want you to learn it and then be able to like learn what is the main thing. But if you like, you can go and still take crypto zombies, but it's your choice. Yeah. So what I'm going to do right now, I'm playing around now. This is just a simple to-do list in terms of a smart contract. Okay, in terms of a smart contract. Now, like I said, we're going to our license identifier, and then this is our pragma statement, and this is the name of our contract to-do list. The type we're taking in is going to be a count, and that means it's going to be a number. And this one, okay. So when we talk about, let me just go back to something I missed. So, all right. So when we talk about function visibility has to do, yes, a function visibility has to do with basically making if either who is calling a particular function. Let's just use that one. Who's calling a particular function. So there's 4 types of function visibility. We have public, private, internal, external. A function that is public basically means that anybody and any contract, both from outside or from inside the contract, can call that function. While a private function basically means that you can only call that function within the contract. That means that another contract, let us say we have 2 contracts, contract A and contract B. Contract B cannot call the function that's inside contract A if that function is private. That means only contract A can call the function. Let us say the function it. The function it in contract A. Only contract A can call the function it. Contract B cannot come and call its function. Do you guys understand? Do you guys understand?
Please repeat what you said, sir.
Okay, now we have 2 contracts, contract A and contract B. Inside contract A, we have the function of eating, like eating food. So now, when we say a function is private, it means that only contract A can call it. That means that only within that contract that it can be called. That means that in your contract A, where we have the it function, that means only contract A have access to that it function. Contract B, there's an outside contract, and a different one, a totally different one, cannot come and call function it in contract A. Now, when we say a function is public, that means that, now keep using the scenario, contract A, a different one, contract B, 2 different contracts. And in contract A, we have the it function there. When we say something is public, that means that A can call the it function. B there's another contract can call the it function. That's what you mean by a function is public. Now, when we say a function is private, that means that A is the only one that can call the it function. B cannot call the it function. That's why they call it private. Now, when we talk about internal function means that A can call it. Any contract that is example that may be a child of A, in terms of, let's just say there's a small letter A contract. A small letter A contract can call the function it that is inside the big A, that is inside the contract A. Small letter A can call the function it. B cannot call it. Now, when we talk about an external contract means that any other contract, like outside contract, can call it, but it cannot just be called within itself. So, okay, I know you will not understand this now, but when you are learning,
I understand.
You understand? Oh, that's very, very good. Thank you. So, like, when you're going through this, that's why I linked it up. You'll be able to understand, okay, when we say a function is public means that anyone can call it. Contract A, contract B, even contract Z can call a public function. So when you see a function, when you mean external means that, okay, only outside, only contract Z. Let's say this function is in contract A. That means that contract A cannot call it. But contract Z, contract B, contract P can all call it. So those are the little things. But as you play around with code more, you understand it more. So back to where was I? Now, in these terms, you saw like this was a data type and we called it public. That means that anyone can call this count. Now, when we talked about intermediate, we're talking about structs. Struct is basically a way of keeping, okay, now a different variety. This is like a struct is more like a package of different types. We have different data types. Now, if you want someone to be able to access, there are different data types, but you want to package them into one, you can use a struct. That way you can be able to access different data types. So now we have this struct called tags. And when you think about a task, you think about, okay, we have a number. Like example, you have to do a to-do list. We're talking about a to-do list, right? And then you want to have, okay, number 1 on the task, and that's what we use and identify our units. The string is basically, like I told you, string is the English word. Okay, number 1, I want to basically I want to take my Web3 course for 2 hours. And that's basically what you want to do. That's your string. Now the boolean is now like, have you done it, yes or no? Boolean is now like completed. You now do your check, yes or no. Now this is how do you guys understand how the struct works?
Yeah, but I don't get the int.
The int, okay. The int is number. Do you know what an integer is?
Yes, I do.
So an integer is a number. So when you say the uint, it's not int, it's uint. That u stands for unassigned integer. Now, when we talk about, there are two types of, they are basically like this int and then this unassigned. So int basically has to do with positive number. You know what positive numbers are, right? Everything with a plus 1, 2, 3, number plus. Why int has to do with like negative. Has to do with like maybe minus 50, minus 40, things like that. That's what int is all about. So now, when we are not talking about, there's something I escaped that I feel like you guys will need it. So now, there's so much you guys have to learn. So let me just do this breakdown of this contract for you. Now, we know we talked about a mapping. A mapping is basically a linkage, a key, and then there's a key, always a key, and there's a value. So now the key here is a uint. Let's just say like now uint is number 1, and then it's not be like number 1. Mapping is now like a tax of, okay. Now when we have 1, 2, 3, we have like different tax. Now imagine if that's like in tax A, you have a breakdown of tax 1, 2, 3. And then there's a tax B that has another breakdown of smaller tax. So this mapping basically helps you check out that, okay, this is a particular tax I'm talking about. Now, in this mapping is more like, okay, the number of the tax I want to do is 1, and then let's just say 1, and it's linked to this tax, and we named it as tax. When you write Solidity, you understand a lot more. In terms of events is more of a way of keeping track of whether something has been done or not. In Solidity is keeping track of, on the blockchain example, when someone makes a transfer. Have you guys actually used, how many of you have actually tried to send crypto?
I have.
You have? Okay. Yeah. And now, let us say the event is the way we used to mark that. Like example, when someone sends money, you are basically on, like now on the blockchain, you are basically, let's just say you are triggering an event, like you're creating an event. And now when someone else, example, they say that they have credited you, that's basically what we are expecting to return. In terms of like, you now be like, how does, like example, you now be like, how do these people know that I have sent the money? It's because of once you submitted everything that they asked for, it's basically like was a trigger, and then what we're expecting you to read, what we're expecting, if it comes back, then another trigger, another event, or it's triggered. So now in this one, let's just say one event tax created is a trigger, event tax completed is another trigger. No, I want to create a new tax. I put in, okay, my tax number 4, I want to wash plates. And this is, have I completed it, yes or no? That is basically, this is my task now. Now, and that trigger is now like, oh, when I complete it, I want to play that, oh, number 4, I have completed it, and that's it true. This is another event. These are like ways of tracking. One was, I want to create, one was basically creating an event, another one was basically completing an event. Now, in terms of the functions, it's not like, oh, we use the keyword function. No, like we said, Solidity is statically typed. We named it, oh, create tags. And in our function, we said that, oh, this is the content of our function. Remember, we said that our function is basically wash plates. Wash plates, now this is it here. The type was string. We said it's a memory. That means it's basically like a temporary storage. And now we have the visibility type. So you guys, I have a question now. This contract here that is public, what does that mean?
It means anyone can access it.
Thank you. It is. Okay, I hope you guys are following.
Yes, I was following.
Okay, because I know that I'm only hearing one person talk. Okay, so I'm trying to see something. I want to do injected Web3. Let me see. Compile. I'm coming. Hey. Alright, so now, sorry, I'm trying to see. Okay, I want to. Hey. Okay, I'll just. This is greater than 0.8. Let me just reduce this. So what this is basically, like I told you, the latest versions of Solidity every time. These are all the versions that have ever existed in Solidity. So I'm trying to see what's going on here, because if I want to compile this. Okay, back to where we were. Now let's just say creating our tags. And our account, remember, like we created, our account is basically what keeps track of whether we are increasing or reducing. So count is +1. This is now a mapping. This is a way of accessing a mapping. We said that, remember this mapping, we called it, this mapping is called tags. And then inside this tags, we said that it has to be a number, right? A uint, that's a number. And now don't forget that our number is this uint here. Look at number 14 is it takes in, that means the key is a number. Number 6, we named our key as count. Do you get? So now going back to number 29, this year, number 29. Sorry, I want to do something quickly and check out. So let me just copy this contract again. Let's be on the safe side of stuff. Sorry, let me just refresh it. So if someone have a question, okay, Kiki, you can talk.
Okay, so I wanted to ask, is there a way you can manipulate the contract?
Yes, I can. This is basically something I wrote down. What I'm trying to do right now is that I'm trying to deploy it. Deploying it basically allow me to now do, like, show you guys a test running of it. So that's what I'm waiting for here, but I don't know why this is happening. So it's meant to like compile. Okay, yes, it works. So once I'm done explaining to you guys, I'm going to like deploy it and then show you guys. We now do an interactive, like I'll deploy it and then we'll now play around with it. Do you have something else to say? Okay.
Yeah.
All
So
right.
sorry, please. Learning of Solidity would let you like would enable you to like be able to like create a contract from scratch, just like the way you did.
Yes.
Oh, that's nice. Okay.
Yeah, it does. And basically building smart contracts, you now be able to build on Ethereum. There are other blockchains out there, but you learn their languages for them. Like example, the Solana blockchain, and them they use Rust. So they use Rust for that one. But I know that there are other blockchains out there. So some you can probably use Solidity on them. So they are EVM compatible. EVM is like the engine. EVM stands for Ethereum Virtual Machine, It's like the engine that powers everything here. You know how in a car you have an engine, so EVM is like the engine. So what I was doing right here was I was trying to compile it so that at the end I would deploy it to you, and then we can be more practical with this. We can do more with practical, but right now I'm trying to just explain this contract to you. So now we said create tax. I remember that we said that our account is basically a way of keeping track of whether our taxes, like when you're putting 1, 2, 3, it's all increasing by 1, right? So this count, when we said count, that means that plus 1. So now this tax, and then it's the let's see, the key we're using to access this tax, this number 14, the name of it, it's our mapping, and we have a key, and this is our value. The value is basic. This value is just like the short form of this struct. Can you see? This is the name of the struct. This is the struct here. And then we're trying to say that, if I call 1, that's the key, it should lead me to whatever count we're doing. But now we named our mapping as tax. So back to number 29, we said our tax, but want to use a count. That means a number is equals to the tax. Which is going to be our struct. Then we are putting it the number, the content, and then we're making it false. That means this is us creating a tax. That means that this is us just creating that number 4, wash plates, I've not done it, so that's the first. And then it's now, whenever you create an event, you always have to emit what it will return. So now it will emit that the tax created, number 4, the content, and you have not done it, and that's like sealed. Now the second one we're doing is basically a checking whether your tax has been done. For you to check, it's basically like, now it's more of let's just say this was more of a setter function, and this is more of a getter function. But now this one, we want to get whether we have done our tax, and what we pass in is probably the number of the tax. Example, how you do serial number, right? 0, 1, 2, 3, 4. So now we put in the number of the tax. That means it's a public function, anyone can call it. Now when you are saying this about infinite gas, every transaction on the blockchain costs gas. That means that, and public is a good thing in terms of, yes, when you are learning, you can make all your contracts public unless otherwise. But know that public, when you say define a function as public, it costs more gas in terms of like everything that we're writing like this. It's all going to be like money that is being paid. But now on your own end, now we're going to be making use of fake ether. It's not real. It's more like it's fake ether, but you can use it to just be playing around and understanding the contracts more. So public, that's why you're seeing something like infinite gas, because of it shows that there's no way of saying if this contract, like how much gas this contract, this little function will cost, because we're using public. People normally advise that if you are using a contract that it should be called from outside, that they say they should use external listed. It's advisable. It depends on what you want. External. If it's a contract that will be called from outside, use external. So let me just wrap up this one so we can deploy it, and then for that I'll share the resources to you and we can call it a night. So now in checking our tax, it takes in, like, you pass in the number. That means the if it's tax number 4, then this tax here is this is our struct. It will now go. Just know that in Solidity we name a lot of things. The naming is not like, we want to access this tax, and it's like memory. Memory is, like I said, temporary memory, temporary storage. And then we name this tax here equals to this underscore tax. Now, and then is equals to this mapping that we created. I said that a mapping is like the unit to the tax. Now, this is the key, and then the value is the tax. So now they're asking you that, you want to access the mapping, which is what? Tax. The mapping that is tax. How do you want to access it? Like, which one do you want to access? And then you don't put that, I want to access number 4 tax. So that means that you're changing that, in under our tags, we want to change it to completed. That's a boolean. But instead of, normally it's a false. Like all tags at first is false. But now you want to change it into a true. That means that this tax ID is equals to tax again. And then it's just like a way of changing that, okay, what we did, it's not, we have done it now, and it's now a true. And then emitting tax is just like a way of replicating it all over the blockchain that we have done it. So this is a simple smart contract. When you are reviewing the document, especially Solidity by example, you will see lots of smart contract. At first, you don't have to get everything, but over time, you will understand. So let's move on to this now. Now, when it comes to Solidity, this is like where like I told you, now, there are different versions of Solidity that keeps coming out. The latest one so far is 18, and they are probably this is 18, and there are more things coming up or new changes there, and it depends. That's when you're writing you are defining your pragma statement, you should use this sign, this caret sign, which means greater than. It means that all versions that are greater than 0.80, that's what we're using. So now the next thing you have to just do is compile. And as you can see, this is compiler here. If you have an error, let me give you an example. It will not want to compile. Can you see? You won't be able to compile because of there's an error, and it even shows you here that, I am expecting this, but I did not get this. So let me just give you another one again. So let me just say that that's just a basic simple one. Let me see. We remove public. Okay, if you don't put public, guys, and asking again about that, if you remove this public, every function that you create, they are defaultly public. It's now, we just put public example just for more like making us more aware of it. But every function, if you don't put public, it's not the end of the world. Okay. No visibility. Did you intend to put public? It's advisable to put public, but if you don't put public, it's basically lets you know that okay, this function basically is it public or not. But it's every function without public itself, it's actually defaultly public. So now let's just compile this, and now let's come to this is where we deploy. Now you are playing online, so these are different accounts, and they gave you fake Ether if only this money was real. And these are different addresses. Remember I told you that you interact over the blockchain with addresses. So these are different addresses that they are giving to you with different Ether. Now when we talk about environment, this is like a way of you, just like how we have our VS Code where we build on, and I told you that we use hard hats in VS Code. These are like different environments. Now since you are playing within here, it's just use Remix London. Now when you want to connect to your MetaMask, that means this your application here, MetaMask. This is MetaMask here. You should use it if you want to like connect over. If you want to connect to your MetaMask and like do things that they all deploy, like you get to see it all. You make use of this is MetaMask here. If you don't have this as an extension on your laptop, you should get one. And please, it's the norm that you should have a MetaMask account that is for your development only. Never put real money in your dev account unless you want to test something over the mainnet. That means over the live environment. All the things we are doing here is test. If you want to send real money, it's advisable that you should create another account, another wallet that way that has a different seed phrase from your dev account. Because we have had scenarios where people like now developers. Hello? Is there any question? We've had the case whereby developers. I can't hear you.
No questions.
Okay. So I've had the case whereby developers, they put in like real money into their developer account, and then they go and they push their seed phrase online. The reason why their private key is online, and why they do that is because when you are working with hard hats, there's a file you have to create .env, whereby you need to put in your private keys there. But now the mistake some people do is the fact that under you're meant to have a git ignore file whereby you are telling your VS Code that, oh, these particular files, you don't want it to push them online, you should ignore them. So that means you are manually meant to go to your git ignore file and put that, oh, ignore my .env. So your .env contains your private key. But let's say that you don't do that and you push it like that. Your private keys are out there and they are bots online that are crawling GitHub, crawling different platforms. And once they steal your private key, they will go to the account and drain everything that is there. If it's real money, they would, let's say you put $100 there and was just a mistake, but they will remove the $100 immediately. You may not even know. You may not know, but as if once they have access to your private key, that's the end of the account. So whatever you're doing out there, let's say even if it's fake Ether, some bots go and collect fake Ether. I don't know why, but they do that. So please have an account separate for your development that is different from your main account. Now moving on to what we are doing now. So I've explained to you the different accounts, Ether, environments, and then in terms of like gas, the lowest denominator is we have Way, we have Gay, Fini, Ether. Ether is like the baba of them all, but for gas we use mostly like Way. Now let's just say we want to deploy, and we have deployed the smart contracts. Now, all right. So now this one is more like a deploying the contract whereby, remember what we said about these ones are basically the functions, and they're like a way like now. I'm thinking of read and write. Okay. So now when you see blue tabs are basically means that you just want to read the state of the blue here means that you want to read the state of the blockchain. That means that, oh, whatever you are pressing will just return an information for you. You're not changing it. But orange represents right. That means that you are inputting things that may change the state of the blockchain. Now let me just say count is 0 because we haven't done anything here. And if you want to say tax 1, it should not. It's basically, what is it saying? It's saying the ID is 0. We don't have anything there. We're putting content, which is what we passed here. This is basically like what is the word? There's this word like is the dummy text is content, and then it's basically false. That's what it is here. Now let's now go and do something else again. Let's create a tax. And in creating our tax, let's just say wash plates. And let's create a tax. In washing our plates, now let's see. In our 0, in our tax 1, can you guys see? Hello guys, do you understand? So like now we created a task called wash plate, and then everything starts counting from, I think it's from 0, but let's just say like this is like +1. That means each time we click on count, it's increasing. And now that means that each thing's basically start counting from 1. Each task basically start counting from 1. You don't have a 0. So now we did, okay, we want to search for tax with the ID of 1, and it brought out, okay, tax 1. This is what we wanted. It says that it is wash plates. Sorry, I'm coming on to check something. Completed first. So sorry, give me a minute. Okay, so it's gonna be like this is like 1. Now let's
this is like 1.
Okay, let me try another one. Read my book. Let me start all over again. Want to start again? Let me deploy another one again. And let's just do create tags, and create tags will be more of a read my book. And this is tax 1. Let me do another one again, which says secure the bag. and that's another one again. And then let's just see, call my parents, and this is it here. So let's just see, our count is what it's counting that, oh, we have 3 tags here. Now let's just say we want to find out what's the tax of number 2. When we now click on tax, it's what secure the bag. When we do like number 3, we do what call my parent. Let's say we do number 1, and that's like, that is what we my book. Now let's just say a tax that does not exist. Let's just say we never put in a tax on 5, and it's giving us what 0. That means that there was nothing there. So do you guys understand? Hi guys. So with that,
Hi, did you stop
yeah, I just stop sharing now. Yeah. So do you guys understand? Okay.
I was kind of lost. I was like, because I wasn't really like paying attention. I wanted to do something.
Okay. Should I
But
read?
I think I should be able to find my way by the time you like hang up. You said we should like use Solidity, right? To like learn more about it. Isn't that what you
I
said?
will send you the documents that you will use to like review
Alright,
it all. And no,
alright.
you normally use Remix to just do online development. And this call is being recorded, so you have access to watch it afterwards. Yes, afterwards. This call is about 1 hour, so it's something you can easily watch. And
Thank you so much, ma.
yeah, you're welcome. So if you have any issues, you can ask on the community page, and we'll be available to help you guys out. There's an assignment. Let me show. So I know that you are just learning. Okay, I'm coming, please. I know that you guys are all, you're just learning, and it's normal, it's fine. Just please don't forget to use that Learn Web3 DAO. That's like your go-to, is like your go-to where you should be learning. Now if you want to make some more clarification, you can now go to Solidity by example. So all these things are inside here, so they're all here for you guys. When you are ready, once we are done with the call, I will share the material with you, and you can have access to it. And this is the assignment. I want you to do this with Remix, a voting smart contract. In terms of you could determine that a voting smart contract, that means one person is only allowed to vote once. Or if you are voting, is it a way of tracking that if you are voting, can you vote again? Just play around with the concept of voting. We are in election period in Nigeria, so it works. Secondly is now like learning how to set up hard hat on your VS Code, and then building a smart contract and deploying it there. That may be more hardcore, but once you go through like learn Web3 DAO, you'll be able to understand how to do it more. So you're just meant to do that. This, I know that it may be taxing now for you that are just learning, but we're trying to just fasten your growth. And the last one you're going to do is posting about your learning on social media. You can tag blockchain OAU, tag your Web3. That way you are holding yourself accountable and showing the world that you are in the process of being a blockchain engineer. And if you have any issues, you can also tag me on Twitter also. I'll review it for you. So this is my own Twitter handle here, Blessing Emma. Yeah, okay, you say you have a question.
Yeah, this contract address you like created, because you said something earlier when you were like talking about chain Solana or cryptocurrency having, I don't know how you like said it, but you said they have like a different engine or something, yeah. So I was wondering, this contract address you like created, can you like, is it the same like step, like is it the same thing with Solana if you want to like create a Solana contract address or something? I don't know if you understand me.
Okay, I think you're asking about, can you carry this contract now? I'm not so familiar with Solana. I don't know if Nonce is more familiar. I'm not familiar with Solana blockchain, but I know that people learn Rust. Rust is another different programming language, and they use Rust a lot to build there. So let's just say like now, you know what you are learning is basically Ethereum blockchain development. Like now, you know that there is Bitcoin, there is Ethereum, there's Binance Smart Chain, that is Binance. They have their own blockchain, and then there's even Solana. these are different blockchains, totally different. Now, to build on Bitcoin, you may need to learn their language and even understand their network, Lightning Network. Now, what we are focused on is Ethereum. Why? Because Ethereum is what is mostly built for developers by developers. So that's why like Ethereum is the most popular of them all. And in Ethereum, when you are building on Ethereum, you use Solidity. Binance Smart Chain. You can write Solidity for and deploy it on Binance Smart Chain because of they made their own more. Let me do what the language is the same thing is, but they made their blockchain in such a way that Ethereum developers can also build on Binance Smart Chain. Do you understand? But now, when we talk about Solana, what I just know is that they use Rust. I don't know if you can also use Solidity there. I'm not familiar with it. But I just know that Solana, it is Rust they use. But Binance Smart Chain, you can also use Solidity to write their smart contracts. It has to deploy it on their own network. So do you understand? I hope I answered your question.
Yes, you did.
Okay. Does any other person have a question? Okay. If there's no question, I want to say thank you so much for joining in. I know that today's Sunday and we all had a very busy day. I appreciate you all and good luck in your learning. If you have any questions, feel free to ask on the community page and we will respond to you. Thank you so much.